Recording started. Okay, so Stephen already agreed to take notes. Thanks for that. Let's quickly go over the meeting from last time. Let me quickly share the screen for that. Oh, it seems not to work. Just sharing, let me try.
While you're doing that, the notes link, the Google Doc, is in the chat. If you could add your name and what company you're from in the agenda, under
Perfect.
attendees, that'd be great.
Yeah. Yeah, so I would need to restart my Zoom to share my screen. So I tried without screen sharing. So next time I will have a screen sharing and just install the Zoom workplace here. Yeah, so for those who did not participate or didn't know, so I posted a link to the last meeting's notes in the chat here. And so actually what we spent our time with was actually setting up the cadence and discussing.
No, I'm not, but I had to do something.
Sorry. And we agreed that we will meet every second and fourth Tuesday of the month and rotate around the time zone. So as of today, we have Asia, Europe. I think the next one will be Asia, US, and then we have US, Europe, and then just taking turns. And this took some time to figure out and get all the time zones in. And the second thing was the nomination actually for chairs and co-chairs. So as you might know, Chris, who initiated this is the chair for that's interesting. And he will get support from Emily Ruppel from Bosch US, and here in Europe it's Stephen from Atom, I think, and me from Siemens, Dominic, and in Asia it's Jin from Huawei. Is it?
Intel.
Intel. Oh, sorry. Yeah, sorry for that. Yeah, and this actually was our last meeting. And did I forget something? Are there any questions?
Yeah, I have a question.
Yeah.
It's not about last time. It's about Zulip and Zulip Chat.
Yes.
The whip embedded kind of thread or channel is going to be winded down. And there are some discussions like the varsity to target discussion and other discussions like that were about the hardware platform for the embedded world. So some kind of reference boards how to put these conversations or the insights into the Sig Embedded channel. So a very, very basic question.
Sorry, so which you mean the?
I can share a link to this.
Yeah, that would be awesome.
This is Zulip Chat.
Yeah.
And this is just one example that was discussed. Other discussions were also Maximilian Seidler. You know him. Was part of was about the discussion about the hardware platform, which is also on the topic for today's meeting.
Yeah.
Just ask not to lose all those information that.
Yeah. So I assume let me check with the channel owner or somebody that that this channel will not be deleted immediately, but maybe archived, and then I don't know, maybe we can have a large language model figuring out the important information in all these chats, and then we need to preserve them. I mean, we have our own space on GitHub, and especially if there are decisions taken and discussions with a conclusion, we can put all this in our area on the GitHub to preserve it. So it's totally a valid point that we need to preserve the discussions and maybe if there are ongoing discussions, we need to move them. But let's look over the very long channel if we can at least find the conclusions there, if there are any.
I think it's possible to move topics to different channels, so we could just do that.
Yeah, maybe something like this. Yeah, but a valid point. So everything is different now, and everything is a little bit yeah. We need to find our pace, let's say. So here's this one. Yeah. Okay. I mean, what's the right now the general feeling? If would it be better to like summarize the channel and put it in a document, or just move all the discussions to the new channel? So
I think we can just move the whole discussion to that new channel. It feels like it's possible in Zulip, so I don't see a reason why wouldn't we do that.
Yeah, sure. Yeah. I mean,
as far as I can see, I'm sorry for interrupting. As far as I can see, it's just you can do it if you have the rights in doing it. So that's just it, and then just let's. I've put links to two discussions. I think they are worthwhile in preserving them, and then just let's do and then go on with a state we already have, right?
Yeah, sure. Good point. And let's see. So anyone has an idea how we can figure out who has the rights to move stuff? So I think I don't have the rights, or I'm pretty sure that I don't have the rights to move stuff.
I think Nick likely has access to this. So I already replied to that thread that he started. So hopefully we'll find a person. If it's not him, probably we'll be able to point out a person who have access to it.
Sure. Cool. Yeah. Thanks. Yeah. Okay. Cool. So first thing cleared. Any other general questions before we dive into the hardware topic?
I think we want to have some kind of topic pipeline for the meetings. Sometimes, so some topics may go a very long time. So we should from time to time have some updates and also a discussion about that.
Yeah, definitely. So this is something which we need to work on. We can do it today or take some more time. So I would say the basis for this topic pipeline would, in my opinion, or what I would suggest would be the proposal we made in the governance repository. So here we already like defined a couple of topics and what we need to do eventually and in a timely manner is to sort them out and then really create like work packages out of that. And because it's like pretty broad areas like it's about the evaluation of component model and stuff like that, and these are all like pretty big topics, and we need to break them down. And then we can, as you said, and this is totally fair, put it in a kind of pipeline and see how things evolve and track over time, because there are a lot of topics in which we might not solve in 2 weeks. So.
Yeah, maybe it would be perfect if we can have all the topics kind of planned for the next month, and so we can do some preparation or study, so that we have people in the meeting can have some shared base or knowledge. Otherwise, just quite a few people know details about this topic, and others can't really participate in the discussion.
Yeah. So I posted a link to the proposal again, and I mean at this point I'm pretty open, as we are like finding our pace, to be honest, and then it's the first meeting, and then we could either, as Ralph suggested, discuss about, so proceed, and in the background just drop ideas in and discuss at the end of the meeting, or we can really like jump on the proposal. So I'm open for any route. Any suggestions or any?
I would, well, I don't, as of now, I don't see a reason going another path than that one that is in the proposal you already posted, right? You can see it on the in the picture. The embedded SIG is established. The next one could be or should be a technical scope white paper containing also, what is our recommendation for reference boards, FPUs, MMUs, or does the processor have an MPU, etc. And then going through the areas. So the innovation, the component model. What do we do with WASI P1 to WASI P2 with its transitioning and so on and so forth, and also this compatibility questions, right? So which are very important for us, because in the embedded domain we cannot update mostly the runtime day by day, right? It's just not possible, and I guess these things are the important ones. However, I'm free to discuss if there are more to come. I'm pretty sure there are, but
sure.
I would start with it.
Yeah, and there will be a lot of going outside of the scope. I mean, the idea right now in the discussion is, so discussion is not to deviate from the proposal as of today. But the proposal is fresh enough that it's correct enough, I would say. The proposal would be, we would like to already start the discussion about like long-running work packages, which might start now. So I think with our topmost priority, we should work on the technical scope white paper, because it's like the base of our future operation. But if it's already an idea, I don't know, I don't know, look into things from area 1 or 2, starting then. So, but I get that we would start with the hardware platform discussion here, or is there any other idea? So there's a raised hand.
Yeah, no, just a suggestion for maybe going forward. I presume some of the topics might be particularly interested to some people and some of them might not. So maybe we can have some concept of a work stream leader as a person who's sort of driving a specific part of the what we do in this interest group, and then gives regular updates when there's something to update, and work offline with other people who might be interested in the same topic, and then use only this meeting really for updates or some discussions that require a broader audience.
Yeah,
I don't know, it's just an idea.
Yeah, sure. So I totally agree. So let's say the majority of the technical work will happen outside of this meeting, and then we basically just update each other. And so still, I think it's a good idea to have the white paper first, and then derive the steps from that. So what I would propose, so taking all this in, and it's totally valid, and maybe if you have an idea for a background task you think shall start immediately or in a timely manner, just as Ralph suggested, put in the chat, and then I would slowly move over to the hardware discussion. Yes. So quickly open the Zulip. Okay. So I think I need to restart my Zoom to share something, or somebody, some of you can share like a scratchpad. Where's the scratchpad in Zoom? Maybe then we can get started. So what I would propose here is to actually, there's a raised hand. 1 second. To just have an open discussion about like the target hardware, that we somewhere can find, like, let's say minimum, maximum, and sweet spot or something like this. And this would be in terms, as discussed, of memory, CPU performance, and also like memory protection management and stuff like that. But now, Ralph, you have a question or something to add?
Yeah, one question regarding to the hardware. Should we be focusing on those hardware some participants are already working on, or we want to define a kind of a wide spectrum for all the embedded world?
I think I found my microphone. Did I?
Yeah. Hi.
Yeah.
Thank goodness. I dislike it when I'm on Windows. It bothers me. So two things. One is I type really fast, and so I try not to interrupt the flow of conversation. So I dump a bunch of chat notes in there. Please, if it bothers you or something, please let me know. That's sort of how I do my stream of consciousness, and you can pick up what you like and destroy the rest. So I just want to let people know. And the other thing is, I think the target devices, for example, should be run the whole gamut. There are going to be, I've always felt, and made it clear that there's going to be an event horizon for various technologies that we pursue, including the component model. You get down within certain constraints, but I think we actually should challenge the heck out of the engineers and really have a wide array. You've got to make sure our primary targets are in there, those things that we really do want to run on. But we should also have a couple of clear examples where it's actually very difficult to run things. as a way of setting the standard for where we're trying to reach, because, you know, the work we're trying to do here should result in something that everybody could, in theory, use in the 80 or 90% case. So I'm certainly open for a wide array of devices.
Yeah. And yeah, thanks for the input, and I hope this answers your question, also. Yeah, so it's a balance. So if we let's say if we make the array too wide, then maybe we lose a little bit focus, and then it's hard to get things done if there are so many devices in. I totally agree with Ralph that we should put some challenging borders in. So let's say if we only focus on things which are already run today, then it's boring. So
but the other thing that we found, that like, it took a long time to, in the conversation in the Zulip, for example, when we're going over this, it seemed to take a long time to get to concrete examples. But then when we got to concrete examples, we were able to lay out 3 or 4 kind of devices and the specific constraints that we were interested in. I definitely think we should start with those. But the critical focus here is, if we're going to find a way to really realistically address engineering challenges, we really do need concrete specifics.
Yeah.
So yes, any device could be put on the list, but it's one of those things where we should also make it clear, you know, how many people are interested in those devices, you know, like what the weight is. For example, there are going to be devices that are almost impossible to reach with some kind of coherent component model, let's say. In those cases, there may be some people who are interested in that case, and they're just not the bulk of the conversation here, but they report back where they are and things like this. People can then flow between devices when they're doing their work. So it might be that this 3 months, I'm really focused on this device profile, shall we say. And then all of a sudden I've got a use case for a different profile. And so I'm like, okay, y'all have that. I'm going to be over here for a little while, kind of thing. So that's also possible too. So the precision of our devices in the document at a start will help us move faster, no matter how many devices we have.
Definitely, yeah. So there's another raised hand, and then
so that's me. Just real quick, I think I agree with the discussion so far. I think perhaps we introduce some sort of priority or tiering system in this, giving preference to the things that are more concrete, people are working on now, more active. Make those sort of priority 1, priority 0, and then there might be other things that are way far on that spectrum, like Ralph was talking about, that are more aspirational, and then we can use that to guide the conversation.
Yeah, definitely. So maybe as a working mode right now, do you see the whiteboard I just opened? And can you access it, or is it just on my screen? Sorry, I'm not very familiar with Zoom. Maybe I should have done a Zoom masterclass before. Awesome. So maybe what we could start with, and I just use the first sticky for that, and I put in. So for us, or for me, one of the interesting classes, the like Cortex M4 class, where we face, like, let's say 250K of RAM, something like this, and then like 150 megahertz, something in this range. So this would address a lot of my use cases, let's say, currently as a hardware device class. It's mostly ST, but this is from hardware device class, and maybe we can just put the things in which would address our use case, and also pull the things from the Zulip, and then we can try to, let's say, put them in context or create a range with that. So I feel I would be somewhere in the middle here. And no MPU I write down, and maybe then we can create a picture together and say, okay, this is other things. I don't know. Can you access the whiteboard? I already saw it. So
yeah,
maybe.
Just a remark, because I will get a non-maskable interrupt in 2 minutes. To me, interesting would also be the combination with a microcontroller operating system, like FreeRTOS, Natex, Zephyr, etc.
Yeah.
I think that's necessary also to
Yeah.
taking this into account. And CPU wise, I would also like to see something like an extensor, ESP32 kind of thing. That would be nice. And maybe for more, from my perspective, more future like would be a RISC-V also, something like that.
Yeah. But yeah, okay, but understood, yeah. But
Yeah.
so but RISC-V in like this 250K RAM realm more or less, or
Yeah.
so nothing to run Linux on. Yeah. Understood.
Because I think if it's running on those kind of systems, it's easier to go up.
Yeah.
For a
Yeah. So I
something.
yeah, I totally agree with the operating system. I think it can be a little bit detached, the discussion from the actually target hardware. But you're right. So we should if we have like a target in mind, we also should have a target of operating systems in mind. So I have something which I would like to do, and I have something which I'm, let's say, obliged to do because of business reasons. And yeah, let's discuss that. Okay. So okay, so maybe if I would like to ask you to put your ideas on the board, or your things where you would feel comfortable, and at the same time I try to find things in the Zulip chat, which I think is not so an easy task. Let's see if I can find some proposal from there, or if you find something, just put it on the board, please. And maybe take is there a timer in here, like 5 minutes or like this?
Hey everyone, while you're doing work, I've just discovered that I have the power to move messages between channels in Zulip. I do not have the power to move entire topics, but I can move messages. Unless anybody asks me to do so, I'm not going to, because maybe Nick or somebody can do it, you know, en masse as a topic. Just move the topics, but there it is.
Yeah. So, is there anyone who wants to put anything on the board here, or shall we discuss? So I just, because I'm a lazy guy, I just copied from the Zulip channel.
Yeah, I would start with that, because we did start laying some things down.
Yeah.
Otherwise, everybody's brain would go back to, oh, let me see. What?
Yeah. So, if you're all done, if you somebody's writing here, I totally agree. I like the multi-core approach. Maybe even I would extend it to heterogeneous multi-cores. So not like two M4, but maybe an M0 and an M4, or maybe even an A and an M processor or something like this. So system on a chip stuff. Okay. Yes. So I copied the thing from Zulip. Sorry, it took me some time to find. I'm not able to click links correctly. Yeah.
One quick thing, Dominic. I'm taking some notes on this, but I assume that we'll just capture this diagram and we'll paste that in the notes. So if you could send that over after, that'd be great. Otherwise, I'm gonna very quickly lose coherency with notes.
No. I think the whiteboard is stored in this meeting and it's recorded and stuff like that. So it's not lost. Yeah. So I think there's no need right now to put a screenshot in now. Yeah, you're right. Yeah. There's a question about RAM listed. So for me, so to answer this question quickly before we jump into this one, for me, the RAM I have here is really the RAM of my target system. This is like lower end, so we can get a little bit up, but this would be the RAM for the target system. So there are some requirements here for battery-driven stuff. So newer devices or greenfield will have a little bit more RAM, like a megabyte is more the standard right now. But yeah. Does this answer the question? Yeah. Yeah. So is there any addition to the thing I posted from the Zulip channel here?
I just added a bare metal environment with a Rust executable because that would be dear to my heart.
This would be, sorry, I didn't get the second half.
So because actually having a bare metal Rust example, and I was looking for some execution environment which would also be Rust based. I think Wasm time would be a bit too large for an embedded target yet, but maybe Wasm might be an option there. So this would be something I really would like to add there, because it would just add up a new environment.
Yeah. I mean, for bare metal, you would need no standard, but maybe I need to look into this, or more or less no standard for that. Yeah, but it's a good idea to like maybe this is then an option for like these super tiny devices if we talk about 250K or less. Yeah.
One thing I would add, I know it's not really a hardware topic, but if you look up embedded and try to figure out and define what an embedded system is, oftentimes they talk about the usage of the device. It's part of another system. It's headless. It's got a single purpose. It's not a general purpose computing system. And while those are not attributes of hardware, they do impact the design and the selection of hardware, right? Because many of these systems have to run for very, very long periods of time without being interrupted and things of that nature. So I think it's potentially worth weaving that into our definition a little bit, because I think it does bear on the types of hardware you have. I don't know if that makes sense to everyone.
Yeah, it totally makes sense to me. Remember that a lot of our various execution environments will be constrained by the environment it's in, not by the hardware.
Yeah.
And so while we should, like I would imagine, I don't want to say should, but I'll just speak for myself. While I would imagine it would be most productive to start with an MVP that's based on hardware, right? An MVP list, that is, and matrix based on hardware. I think what we will do instantly, for example, Chi's question about RAM for the whole thing versus RAM for the WASM app, for example, that's an environment situation that is like, is it bare metal? Is it not bare metal? Is it constrained in some other way, for example? So I think all of those contexts will fall out of the hardware matrix, but I absolutely think that all of those affect the execution and they affect what you want to do as engineers and as business people. So they definitely are in scope for like putting in another column, putting in notes, putting in whatever, at least first before, and it may fall out that that's a good way of organizing our thoughts as well.
I mean, yeah, yes, I mean, this is the core, but this is, I think, or at least for me, this is actually one potential of the WebAssembly on embedded devices, that you can move out of the single purpose. I mean, it will still, the base runtime will still be single purpose, and it will be mostly fitted to the environment it needs to run in. So talking about if you have a thing which needs to run out of a battery for a very long time, you have a lot of constraints to the hardware and the software running on it. So this will not go away, but like adding some let's say flexibility or some multi-purpose stuff on top. So it's limited. So how many concurrent WebAssemblies you can run on a thing? If it's tiny, if it's battery driven, it's pretty limited. I mean, concurrency in the end, if it's single core, is also something complicated. Okay. Are there questions to this list, or are we, let's say, are we able to sort it by size? So what? So I would usually feel that the RISC-V stuff would be like the most potent things. I mean, RISC-V is a spectrum, so it's really hard to group it somewhere.
Are we targeting 32-bit or 64-bit RISC-V? Because 64-bit RISC-V would be capable of running Linux, so it doesn't feel really that embedded. So I would assume that it's an RV32.
I think I would say, yeah. So if it's a thing which can run an embedded Linux, so it's, I mean, it's pretty much an edge case, but I would say if it can run embedded Linux, then maybe the constraints we are talking about do not really apply. Maybe if we look a little bit into timing constraints, if we go that route, but I would say in general, like our, I think the one of the core topics is actually the available memory and processing power, and if you can run embedded Linux on it, the RAM, for the things we are doing, RAM shouldn't be of an issue. Shouldn't be a problem for us, I think. I don't know how you feel about this, so, but
I think the location where the challenges exist is the proper place to be locating ourselves. So if you could run a full Linux, right, you may have challenges because you don't have a lot of memory or something else, right? But the truth is that that's something that, you know, intelligent engineers can work with. So it doesn't feel like it's a challenge per se. It feels like it's work, which is different. So if you get past that point, you're in the space where we're working on challenges. And I think that the core of the list here should be working on challenges rather than just stuff where it's like, okay, I got to sit down and do a bunch of work.
Yeah. And
But I don't think
totally
you
agree.
yeah, but I don't think you should get too hung up on as much. Oh, this is just just my opinion. You shouldn't get hung up on what is embedded. You should get hung up on where is the challenge limit? Where is that point where we're getting as small as we can get, but when we get there, we're discovering that certain constraints affect what we do in a fundamental way at the, for example, component model level, but at the type level, the runtime level, things like this. At that location, you're embedded in some way. You know, you're not running generalized compute and stuff. So I think that's the way to think about your problem space without getting like embedded is a marketing term, just like cloud or edge or IoT. It's like, let's work at the hard problems that we share that are really at that limit. And that's where we should be.
Yeah. I mean, this is actually a pretty valid point, and maybe we jumped a little bit too quick to conclusions. I mean, now looking at the hardware, and maybe I'm personally a little bit biased here, but so for me, it's foremost an available run problem. So how much memory do we have available? This for me is the, let's say, the biggest challenge, but you might have different challenges. I mean,
no, but I think that's exactly so. For example, each one of us might have an agreement or an addition to that challenge. I think your statement of a challenge is absolutely correct, right? And I'm just saying how much of a memory constraint is embedded and how much isn't. It's like, right? But I mean, your statement of your interest about where the limits are, that's embedded. That's like, okay, that's a real problem. You got to work on it.
And yeah, so and this is where we get clear. So if I talk to my backend Kubernetes guys, they only have little memory left if it's like 1 GB free or something like this. But I think we are talking really about some. So this is then constraint for them, but yeah, and we need to like find a spot for us. So, but it's, I think, and this is, I mean, I'm pretty much focused on memory, and I think this is like the thing which will annoy us the most. But also looking at things we do. So let's say low power on the one hand, but also like factory automation. So moving things around where like timing is crucial, and like being jitter free is crucial. So I need to rely on certain things to happen at a certain time without left and right. So I would also say performance in a way of how much would it slow down the CPU, and how much would it influence my real-time capabilities?
These are great criteria, I think. And I think what I would suggest for everybody is like you just volunteered where your focus area is, right? Like where you think the problem space is in your environment. You should write that down here on the notes, you know, somewhere. And say, hey, here's where I think the problem space, the edge of the hard problems lies, right? And then everybody else should weigh in too, because they're either going to agree. Uh-oh, my workers are here. I'll step out for a moment and be back.
Yeah, sure. Yeah, so
One thing.
I'm just
Sorry, I was gonna say one thing I would add to your RAM. I think RAM, or the constraint thereof with RAM, is one thing, but I think how that memory gets allocated, the characteristics of that memory. So for example, a lot of times you don't have fancy things like virtual memory, right? And so dynamic allocation of memory often is a huge problem on these machines, because you create these holes, and on a device that has 256K, those holes quickly become an issue, especially when you don't have virtual memory where you can move things around. And I think with WebAssembly, we have the option to maybe bring some of that capability to the embedded space, right? Because if I'm running in this virtualized environment and I run out of memory, I potentially can reorganize memory underneath the WebAssembly runtime and fix that issue, where on a traditional embedded system, I might not. So going back to those big challenges that Ralph was talking about, maybe some of those things are what's going to really drive that discussion. So I think getting into some of the details around the specifics of that, and the sort of the texture and the characteristics of those constraints, I think will be really what we need to focus on.
Yeah. So just let me right. So I put your dynamic memory thing in, which is pretty good point. Yeah.
Also, just one quick point of order. We're about 9 minutes from the end of our meeting,
Yes,
so we probably want to stop. I would suggest 2 minutes before the top of the hour, just so we can wrap and capture any action items.
Yeah. So I have planned for, or I would say like 5 minutes as a kick out or wrap up. Would be okay, or 2 or 3, or how many do you think? You suggested 2, so we can also do 2. Yeah.
Five's good. I think as long as we can capture action items, that's my concern.
Yeah, definitely. So let's make it 5, I think. Yeah. So okay. So I wrote down some of the things we discussed in the problem space. So to recap quickly, the available RAM is interesting. Then the memory fragmentation is a huge issue always. So how to deal with dynamic memory, or even how WebAssembly offers new ways of doing this. And what happens to our real-time capabilities, and what is the overall performance penalty? So so I can be low performance but still be real-time. So this is like this is why I put it in 2 different points, because for me it's a different thing. So I can still be slow but be on time. So this is what I mean here. Are there criteria which we missed right now? So what about the sandboxing part? Is this like a general WebAssembly thing, or?
I'd like to go back real quick to your real time and predictability. I think one of the things, at least, that got me interested in WebAssembly in this space was predictable execution, and being able to get run-to-run consistency. And so again, I think back in the use case of things that require embedded, having something that I'll use an example that has a big garbage collection sometimes, but sometimes not. That's hard to deal with, right? And I know they've addressed that in embedded Java, but that's something that's nice that we have as a quality today in WebAssembly. Keeping that and kind of leaning into that, because I think a lot of the scenarios we deal with require that predictability. A lot of times people say real time, and they really think fast or very responsive, but really they're talking about predictable, right?
Yeah. So this is really important, and this is this is why I would like to keep it in. And thanks for reaffirming that whatever solution we are going to look at, so let it be preview 1 or 2, or maybe we come up with a preview 3, I don't know. And if we look into system interface stuff, and we always need to have this predictability in mind. So let's say if there's a solution which takes is undeterministic, then it might not be fitting. So we are close to wrap up. Does anyone want to add something to this list here? Three, two, one. Then I would first of all thank you all for the discussion, and then we can maybe go to the action items, if there are any. Are there any? So at least there's one to summarize the concept board in something as a like a document. So I can take this over and start a document on this, what we discussed today, and maybe they can follow up with it.
Yeah, hi Dominic. I think we really have a good start today, and after this meeting, maybe we can have a little bit offline discussion about how to kind of postmortem for the kickoff meeting, and let's see we can organize it efficiently.
Definitely, yeah. So yeah, so thanks for that, and I send an invite, and we still need to get a little the hang of it here. And yeah. Okay. Is there anything someone wants to add? Anything to elaborate? Any suggestion for the next group in 2 weeks, which I think is US Asia, to pick up on? Because if not, I would say that we can conclude this meeting.
Just real quick, I have 3 action items. The first is around the WIP embedded channel and getting those messages moved over. Initially, I have you dedicated to that, Dominic, but is there anybody who's volunteering to shepherd moving those over?
I think Marcin already, if I have the name correct, I think he already just wrote in the channel to Nick if he can move it around. Yeah.
Okay, so that's good. The other 2 I have is you, Dominic, will take this whiteboard and you'll start an actual document. And then the third one is for me to take this scratch note Google Doc and turn it into official meeting notes and post.
Yes, and then there is an action item for like an internal sync with you and Jim.
Okay. So chairs to have. Okay, an internal sync.
Yeah, cool. And I will send the invite. I think I said out loud. Okay, cool. So thanks for bearing with us, and we slowly get there. I think always new. We need to find our pace, but I think it was a pretty productive meeting. And with that, I say thanks again, and see you all around the next time.
Thank you
everyone.
for taking
Thank
the lead.
you.
Bye guys. Bye.
Thank
Yeah.
you.
See you next time.
Bye.